Hi, it's Jeff again, and in this lecture we're going to discuss how to use the aggregation pipeline using the Java driver. We're going to use the zip code dataset that's available on docs.mongodb.org. You can download the dataset from here and use Mongo import to load the dataset into your MongoDB instance. Let's look at the data model. Each document in the zip codes collection has the following fields. The ID is the zip code, the city is the city, there's a state, there's a population with a zip code, and then there's a location, which we won't be using for this particular example. So I've already imported this data, and I've written a simple program that creates a collection object and then iterates through the results using find. And if we run that, we'll see all of the zip code data. Now let's use the aggregation framework to find out something useful about this data. Back to docs.mongodb.org, you can see an example of this where we aggregate the zip codes data by first grouping on the state, and then for each state projecting the sum of the populations of all the zip codes in that state into the total pop field, and then match on results from that group where total population is greater than or equal to 10 million. So essentially it's returning all the states with populations that are above 10 million. So let's look at how we can do that in the Java driver. Well, the first way would just be to copy and paste this syntax into your Java program. So let's implement this same aggregation pipeline in Java. In the Java driver, the pipeline is represented as a list. So the first thing I'll do is create a variable to hold my pipeline, and I'll use the arrays.asList static method to hold the pipeline. So my first stage was a $group, so I'll model this with a document, and first field will be $group, and the value will be a new document with an ID field whose value is $state. And then I'll append to that my projection of total pop, whose value is another document where I sum the pop fields for all the zip codes. So that's my pipeline. Now, instead of using find, I'm going to use the aggregate method. And I'm just going to pass my pipeline into the aggregate method. When I run it, you'll see all of the states and their total populations. Now let's add the second stage of my pipeline. And this will be my match stage. So I'll create another new document for $match. And the value of $match will be a document where specifying the query criteria where total pop is greater than or equal to 10 million. Now when I run it, I'll see only the states whose total pop is greater than 10 million. So this is a little verbose. And if you recall from previous lectures, we had builders for query filters and for updates. And similarly, the 3.1 Java driver added builders for the aggregation framework. So let's get rid of this and change it to use these new builders for aggregation. The builders for aggregation are in a class called aggregates, which has static methods for each of the pipeline stages. Let's start with group, and we'll specify our field, which is $state. And then for the projections, I'm going to use a second builder class called accumulators. This class has a method for all the accumulators, and the one we want to use here is sum. I'm going to call my sum total pop as before, and this will be based on the pop field in the original document, which we refer to as $pop. I can make these a little smaller, and then as before, I also need to put this in a list. Now let's add my match stage, and I can use the filters that we've seen before. We'll again match where total pop is greater than or equal to 10 million. And you can see here that this is quite a lot shorter than what we had before, but the effect is the same. Now, if you are using the shell and you just want to quickly create an aggregation pipeline, you can also use the parse method for document to just quickly copy and paste from shell syntax into Java. Let me show you that really quick. We can go back to our shell example. We can grab this, and let's grab the next one. And we have to change this to 10 million because our JSON parser doesn't understand shell arithmetic. And if we run it, we get the same results. As before, we can statically import these methods to make it a little shorter. Now, one other thing I wanted to note is that, like the find method, the aggregate method returns an iterable, in this case an aggregate iterable. And aggregate iterable has a few methods that apply specifically to the aggregation framework. We can allow a disk use when doing sorts in the aggregation framework. We can specify the batch size, whether to use a cursor or not, and whether to bypass document validation when using the $out aggregation stage. But like find iterable, aggregate iterable also extends Mongo iterable, which means we can iterate over it, we can get the first value, we can map it, we can use for each and into as we did in this example. That's the aggregation framework in Java. We saw how you can specify an aggregate pipeline using 3 different methods. The first is using the document class, the second using the various builder classes, and the third using document parse for quickly creating pipelines from shell syntax.